Elliott. This is me and Steven's final project on hazardous waste. Boink. That's not right. All right. What is hazardous waste? All right. The definition of hazardous waste is a waste with properties that make it dangerous or capable of having a harmful effect on human health or environment. That is taken from the EPA. The classifications of hazardous waste are ignitability, corrosivity, reactivity, and toxicity. Common forms of hazardous waste you've probably seen are batteries and aerosols. If you want to look into some of the like the symbols that they give, you can look at the top right hand image. That shows, like, you might see those on like the back of a tanker truck or something when you're driving down the road. It just helps people identify what's inside the truck. And then the bottom right hand is how the EPA or any other organization would qualify an item as hazardous waste. So they just go through that cascade and answer the questions accordingly.
So why do we care about hazardous waste? It's kind of a silly question, but the downstream effects of the improper disposal and increased creation of this hazardous waste could play a huge detrimental factor to the health and safety of the humans and animals that are in that environment in both the future and the present. So this issue affects many, many things. Just some that we've listed here: the environment. Obviously, there's aspects of decrease in viable land. There's toxic areas. There's groundwater pollution, above water pollution, things like that. There's a lot of health concerns that are attached to hazardous waste, especially when it comes to the lungs of a lot of the inhabitants of that area. And then obviously the economy, because pollution is never good for the economy.
Now, who creates this hazardous waste? So the main producers of hazardous waste are hospitals, factories, schools, and homes. In hospitals, you'll see, like, you probably see, as we just showed on the last slide, some pictures of gloves and stuff washing up into the ocean. That's becoming more common as COVID goes on. Factories and automotive industry, they produce tons of different wastes, but the most common that you might think of is like an aerosol or something coming out of a smokestack. Schools, laboratory uses. I'm sure at some point in all of our lives we've been in like a lab, and there's always the sharps bin, and there's always that cool looking container in the top right hand corner that you pour your liquids into that you got to label. It's really important. Homes generate them as well. We have our batteries, our aerosols, and our cleaners. Stuff like bleach, and then obviously your double A's, triple A's, that kind of thing. In this presentation, we'll be focusing specifically on the environmental effects of the auto industry. That means batteries, air pollutions of factories, and just factory produced hazardous waste in general, and also like some wastes by like cars and stuff like that. If you're looking into like what kind of hazardous waste you might see around your house or just different images of some, you'll see that in the bottom right hand corner of this slide. It's just a nice little reminder just so you can be aware. I didn't know tires was on the list. That's in the bottom left hand corner of the bottom right hand corner image. But yeah, interesting.
So why do batteries affect the environment? So first off, lithium ion batteries. To process the lithium, toxic chemicals are needed, and leaching or spills of these can cause air pollution and soil contamination. So areas of car manufacturers that are using these lithium batteries are obviously a high risk area for that. Then you've got lead-based batteries. The sulfuric acid and lead can contaminate the groundwater and soil as well. Again, high risk areas for any company building cars. Sulfuric acid is also highly corrosive, and the lead has been linked to health effects in children. Obviously, for an example, we've got the Flint water crisis down here. This was not caused from lead from batteries, but it's an example of what these chemicals can do if they get into the wrong ecosystem. I mean, I'm sure there'd be the same effect as if lithium or sulfuric acid got into the water. I mean, it's detrimental, and you can see the comparisons on that picture to your right of what lead water looks like and what clear water looks like there.
In addition to this, um, like this kind of highlights how some companies will take cuts and like try to save money and try to like get around economical stuff. Sorry, that just threw me off. My sister just threw a snowball at my window, but okay, that's fine. We'll keep going. Um, how is hazardous waste being disposed of currently? There are three main ways that we deal with hazardous waste. We recycle, we treat it, and we dispose of it. So if we recycle it, the batteries that are currently made of lead, cadmium, or lithium are dismantled, and a few parts are reused. To put an example to this, only about 70% of lead batteries like the weight of a lead battery can be reused, and it's not a totally efficient process. The treatment is incineration or oxidation to like alter the composition of the hazardous waste. Some treatment processes allow the hazardous waste to be reused, which goes back up to recycle. Disposal. The waste is taken to a landfill. It is disposed of in a way that will mitigate the amount of environmental change to water sources. Damage to water sources, my bad. I.e., it's placed in a drum. So I showed a picture. There's a picture of a drum on the bottom right-hand corner of this slide. And then if you're looking for just like a little cascade, the top right-hand corner of this slide, the white image, is kind of showing how hazardous waste is being disposed of.
So again, how is it being disposed of currently? There's some things to remember that none of these removal processes are really 100% efficient. And because of that, this leads to environmental harm that we are seeing today, like deforestation, things like that. Some companies will try to find loopholes to save money, like the Flint water crisis. Lewis, could you elaborate a little bit on that?
Yeah, so like as we know, like the Flint water crisis was like people wanting to use different like pipes for the city, and essentially they chose lead because it was cheapest, right? Because they're trying to build a city. There's a lot of costs going into it, and when you do that, there's downstream effects that they didn't think of, or maybe they did think of, and they were like, "Oh, nobody will notice. It's not our fault." But a lot of stakeholders like that are surrounding this issue, such as like the auto industry and consumers and stuff like that, all have to consider how their choices impact the others, and how their proposed solutions may also have negative consequences on the other stakeholders involved. So it's a very intricate kind of issue here.
All right, so electric versus gas-powered cars. The topic of hazardous waste is very broad in the auto industry. So there's many different forms of it and debates surrounding each facet of it. So our focus is the impacts of fossil fuel-powered cars like GM or Ford, like the common ones, the ones that we've all known forever, versus the electric-powered cars like Tesla that are now coming into fruition a lot more in today's society. We wanted to define carbon credits, and these are credits that are awarded to companies for good environmental behavior. So they can earn these credits through supporting forests, reducing emissions, or meeting carbon reduction goals. Obviously, Tesla is going to earn a lot more annually than other companies that are a little less eco-friendly when it comes to the emissions from their cars. But there are some loopholes in this system. I mean, there are ways that these companies are able to sell carbon credits. So, I mean, the system, in theory, sounds like a good idea that these companies are being influenced with rewards to reduce their emissions and help the environment. But at the same time, they're allowing the ones that go above and beyond to help the ones that are slacking out a little bit more. So it's really a give and take.
In addition to that, I would say in the next coming slides, keep this in the back of your brain as you consider what the government or whoever invented this incentive program deems as rewardable, right? So you might think, oh, my car, specifically the car, is producing less emissions while I'm driving it, right? Because it's electric. But once we'll show you some data, and then this is just like kind of a little tidbit to keep in the back of your brain. I thought it was interesting. It's a pretty cool topic of the carbon credit system. Later on, we'll discuss like the solutions, the type of things. This might be one of the things that needs to be altered, but we just thought we'd define it here.
So gas power pros. So when we're looking at pros, it's kind of hard to look at the environmental pros to it because there aren't really a lot of them. The positives you do find for gas powered cars are better handling. Some people say they're more fun to drive. There's a lower maintenance cost. and definitely a lower price tag than some of the new expensive electric cars. But like I said, when it comes to the environment, there really aren't too many things to smile about. But when you're looking at it from the actual purchase perspective, there are benefits to getting a gas powered car versus the electric powered car. And then also on the gas powered cars, there's a smaller battery to dispose of, so they're a little more easier to be recycled than if you were to use a electric powered car. So the greenhouse effect, these cars and trucks emit carbon dioxide and other greenhouse gases, which actually astonishingly contribute to about 20%, 1/5 of the United States global warming pollution here. And what happens, these greenhouse gases get trapped in the atmosphere, which causes the worldwide temperatures to rise. Obviously, that's the issue that we're facing right now in our generation. And then some more cons, you got air quality, the chemicals like smog, carbon dioxide that are emitted from every single one of these gas-powered cars is an issue, especially when you look at it from the level of actually the humans that are breathing it at street level. These auto emissions are an immediate health concern because these toxins are emitted so close to our actual living area before they even enter the atmosphere. So on top of the greenhouse effect to be concerned about, there is also some issues with the air quality that we're breathing down here on the street. And then, as we all know, in the past, there's always a risk of oil spills when it comes to these gas-powered companies. They have huge oil mills. We've seen what can happen before, and it really is it's a pretty unfortunate thing that can happen, and an unfortunate con to a pretty unfortunate list, if you ask me.
Yeah.
But Lewis, you got to do the emission data?
Oh yeah, I can do this one. Okay, so just to add some numbers to this, like what's actually going on, to like give a clear cut comparison between the two in a minute. So to produce the standard size car battery, so like the car battery, you open up the hood, you see it, right? To produce it, it requires about like 1/10 of a ton on average to do. The data we found online was in kilograms, so I just converted it over to tons. But then to operate your vehicle, it emits 4.6 metric tons of CO2 per year. So annually, on average, you're getting about 4 to 5-ish tons of CO2. And then in addition to that, or to get that figure, they calculated that every gallon of gas creates about 8,000 or 9,000 grams of carbon dioxide that's emitted into the atmosphere. So there's definitely a lot of emissions going on here. Let's go ahead and check out the electric cars, electric pros. So the pro, there's no emissions, right? It's all electric. There's no combustion. It's just all battery, right? And in addition to that, you're awarded a tax credit. So in the bottom right-hand corner, you can see some of the Tesla models and some of the dollar values that your tax taken away. I don't know how that works. I'm not in finance, but you get it back. Also, it's cheaper to fill up your car with electricity or battery power, right, than gasoline, because gas ain't cheap and it's always fluctuating and whatever. But however, the maintenance is less frequent because it's just one straight up system. There's not, you're not going to be jiggling crap around. I don't know how all that goes, but maintenance is less frequent. And also, it's a very strategic move, because if we're bringing this back into perspective of HPS and stakeholders, if we want to begin to solve the problem, it helps to bring the problem closer to us, right? So if we want to localize all of the emissions to the factories, right? We don't want to have 100,000, however many cars driving around emitting gas, like gas CO2 fumes. We want to keep them, if we keep them all electric and they're only powered by the smokestack in the factory that produces the electricity for the cars, you can centralize the issue to one spot and focus on it at that one spot. Now, the cons to this are, as of right now, there are less accessible charging stations around the globe. I personally have seen like 4 to 5, maybe 6, and I was like, that includes me going to California and places where this is like really a big thing. I'm pretty sure that there are plans to increase the amount of these. Um, yeah, and as I said before, power is produced by a power plant, which is still emissions. Um, and a large battery will eventually need to be disposed of, right? As you can see in the top right hand corner, um, the only image there, that is the size of a Tesla car battery. It is essentially like the bottom of the entire car. Like the car literally just sits right on top of a huge battery. It's literally just an RC car, but it's just massive. Um, you can sell they so what happens is bringing back the idea of carbon credits. So Tesla gets a lot of carbon credits because they have no emissions in their cars, right? So in turn, to make more money, to make more profits, they'll take these credits and say, hey, gas power companies, you guys can produce more emissions, but you got to buy our credits because or else the government will come after you, you know. So it kind of like I think the system is flawed there, and I think the selling of that is a little shady, but that goes on. Definitely a loophole. And the other con to that is ore mining. So they got to pull the lithium out of the ground to make the batteries. And the more cars you get, the more lithium you need, and the more emissions are created by the mining. So that's a con. So here's some emissions data from the electric power cars that we are looking at. So the standard battery in an electric power car is 100 kilowatt per kWh. That's a huge unit. That's crazy. They're manufactured in a facility that is 50 to 70% fossil fuel operated, which in turn emits 15 to 20 tons of CO2 before the car even sees the road, right? So just to put the battery in the car itself, you need 20 tons of CO2. That's a lot, right? And you're not even driving it yet. There's no emissions when you're driving, but that's just a very high initial amount. And also, in general, electric vehicles produce fewer emissions, right? That continue to contribute to climate change and smog than conventional vehicles. Direct emissions include smog-forming pollutants such as nitrogen oxides and other pollutants harmful to human health, and greenhouse gases, primarily carbon dioxide, right? So in the bottom right-hand corner, in the comparative, we're going to show some comparison slides. This is omitted from our calculations in a minute, just so you can see what it looks like and how much carbon is emitted just from the mining process. That's a whole issue in itself. And in this project, we're strictly focusing on emissions of vehicles and emissions of the batteries directly. We're not looking into mining, so that's why I just wanted to show that there, just so you guys can get some perspective and see more light into the issue.
So, results, we wanted to do a little bit of I guess, sort of like a conclusion of what we found from the electric versus gas. And interestingly enough, over a long period of time, the gas-powered car will generate more CO2 emissions annually, obviously. However, if you own an electric-powered car, you really won't be making a positive impact until 5 to 6 years due to like the initial factory impact of creating that vehicle, excluding the mining completely. So to me, that was kind of crazy because in today's society, everyone wants the electric car because it's so good for the environment. But if you look at it to a point of, unless you're going to be committing to driving that car for a very long length of time, you're really doing more bad than you are good. I mean, if you're driving that car for 2 to 3 years, you're not making up for the decrease of emissions as you were to even buy the car in the first place. So back to just strictly electric, it mainly produces the hazardous waste in the form of batteries and is correlated with the CO2 emissions from the power plants, obviously, to make these things. But fossil fuel cars have the battery pollution a little bit less because, like we said, they've got the smaller batteries. But there are huge sources of CO2 emissions coming out of the actual car that we drive every single day. So both of these both of these gas power, electric power cars have correlations with the mining and fracking for these chemicals that they use, which we omitted from a lot of the data that we use. So really the numbers could look a lot worse. We're sugarcoating a little bit for the sake of it. But just thought it was pretty interesting, both of us, that we found out that really the impact of a electric power car isn't felt until you're driving it for usually the length of 2 leases in nowadays.
Mhm.
So
And then, as Steven just said, the leasing options for electric cars are presenting the worst case scenario, right? Because if you think back to last slide, we need 5 to 6 years of driving that electric car in order just to make up for the amount of emissions that it took to just make the battery in the factory, not counting mining. So if you cycle through electric cars in like a 3-year lease program, like a lot of car companies do, the owner will actually be creating a negative effect on the environment because each new car, right, requires a new battery, which is another 15 to 20 tons of CO2 emitted just to make the battery. So our conclusion is the best case scenario if you wish to own an electric vehicle, um, in regards to carbon emissions, is to buy or have ownership of the vehicle and drive it longer than 5 years, which is pretty average, but um, yeah, that's definitely what you want to do. This allows you to start having a positive environmental impact and not continually cycling through massive car batteries. And the best case scenario for gas powered vehicles is essentially just doing what everybody's been telling you to do this entire time, is just try to take public transportation or just reduce the amount of driving you do and just keep it to a minimum, essentially, to try to bring that 4.6 tons of carbon dioxide annual average down to however much you can, just little things like maybe take a bike around campus or something like that if you're relating it back to a college student. But essentially just doing your part. So our solutions to this issue, how are we going to fix this, right? The best hazardous waste saving option here is to buy an electric car and use it for a long period of time. And then also we're considering the option. A lot of this is speculative because people are working towards this, but it's kind of hush hush right now because people got to make money and get their patents and everything. So me and Steven just speculated a little bit. We thought of innovating a new recycling technique to reduce the amount of hazardous waste in emission production, i.e., like if you relating back to the very beginning of the lecture, like the recycle, dispose, and treat options for battery disposal or battery mitigation, environmental stuff. Essentially just making that more efficient and being able to say, instead of 70%, using 70% of a lead battery again, maybe you can use 90 or 80 or something along those lines. Just little steps towards a cleaner future, essentially.
yeah, and back on the topic of batteries, we thought, reusing the batteries for different purposes. So, if you're reusing the batteries, a lot of those chemicals that are getting mined to make them, like the lithium, aren't being mined as much, and it can decrease on emissions. Obviously, it's hard. Batteries run out, but these are like Lewis said, this is a lot of speculation. This is what we think could be the movement towards the future of making this better. So again, things like focus on waste that is already being produced instead of the waste that hasn't yet. So find ways to dispose of the waste in a more eco-friendly way. Again, different recycling methods. But right now, we have so much waste already here. There's a lot of issues that are already happening that maybe it's time to think about the present and not so much the future. So things like that, we wanted to brainstorm, put things on the paper that would kind of get people thinking if they were to be looking at our presentation and trying to make a difference.
Yep. Thank you for your time. Thank you for listening to our fun stuff. Steven, do you want to say anything?
Yeah, it was a great semester, great project. Lewis and I enjoyed it. I hope you guys like the cool car up here. And yeah, it was awesome. Thanks for listening.
All right.